Whether you're curious about how things move, why the sky is blue, or how computers work, a basic grasp of physics and mathematics unlocks a whole new level of appreciation. Well, we are not talking about becoming an astronaut or a scientist, but having a foundational understanding. Think of it like a toolbox. The more tools you have, the more you can build and explore. In today's video, we are going to build a strong foundation on physics as well as mathematics, as well as you will learn which book to read, what is the study approach, and most importantly, how much should you read. My name is Shaunak and you are watching this video on my channel, Physics for Students. Welcome to this fresh new video, the minimum mathematics and physics that you should know. Now, when we talk about this very specific phrase or this term, what is minimum mathematics? This is something we need to know. What is minimum mathematics? Well, minimum mathematics typically refers to the foundational level of mathematical knowledge required to understand and apply basic mathematical concepts. It may vary depending on the context, but generally it includes fundamental arithmetic operation like addition, subtraction, multiple division, basic algebraic expressions, understanding fractions, and basic statistics. So when we talk about this definition, minimum mathematics refer to the basic set of mathematical concepts and skills that individuals need to understand. The question is that who are the individuals? Now, are we talking about you as a student or as a scientist or a physicist or an artist or a very ordinary person like me? Now, when we talk of minimum mathematics, then we are trying to understand the basic mathematical concepts. However, in this video, we are going to extend it a little further, not only the basic, but a little bit more. But when we talk about individuals, the question comes, whom are we addressing to? So the answer to the question is anyone. Because you really don't need to be a physicist or an astronomer or a researcher or even a mathematics teacher in order to have a basic concept or a foundational understanding of minimum mathematics. So mathematics is not just the domain of those people whom I have just talked, like astronomers or researchers or mathematician. It is, you can think of, an indispensable compass which guides us towards success. And this success leads to not only career enhancement, but into various other things which you will be benefited. What are those things? I will explain to you in the next part of the video. So first of all, it helps us in our everyday life. Obviously, because minimum mathematics skills are essential for everyday tasks such as budgeting, shopping, cooking, and explaining and planning activities. Without these skills, individuals may struggle to manage everything. The second thing is obviously problem solving, because mathematical thinking, once you develop, and problem solving skills are valuable beyond the realm of mathematics. So it will help you to analyze situations, identify patterns, formulate hypotheses, and devise strategies to solve problems and efficiently and effectively. As I was telling, yes, decision making is sometimes very important in case you become an entrepreneur or you are just a student or anybody. Decision making is a very important thing, and a mathematical knowledge definitely helps you in decision making. Financial literacy, yes, understanding fundamental mathematical concepts like addition, etc. is crucial for managing finances effectively. From balancing a checkbook to calculating interest rates on loans, mathematical literacy empowers you to make informed, I would say, financial decisions. Also, you can understand the world around us. So mathematics provides a universal language for describing patterns, relationships, and phenomena in the natural human-made world. So for interpreting data in science, if you're doing a research and analyzing trends in economics, mathematics is the key for unlocking this world. And obviously what I think that you are counted among the smarter people, because as you can see that everybody doesn't really want or don't want to go deep into mathematics. So if you really do mathematics and if you really qualify, then you qualify among the smarter people. So just to draw a quick conclusion is that minimum mathematics is important because it helps you with the foundational skills needed to navigate life, make informed decisions, solve problems, think critically, pursue career opportunities, and understand the world that you live around. Now this, obviously there are numerous other examples which will help you to understand the benefits of understanding minimum mathematics, but there are problems. There are understanding where you see that people say you really cannot do mathematics. So coming up in the next part, which I'm going to show you, and it serves as a little bit of motivation that yes, you can do mathematics and this is how you should. Now, if you take the general notion, there are certain things which are being said among the teachers, etc., that which part of human brain is responsible for doing calculations. Our researchers say that number processing and calculation have been shown to activate the inferior parietal lobe regions. Also, some people say that right brain is responsible for creativity and intuition. I would say just ignore them. Whatever the researchers, whatever your friends or whatever the people around you is telling, you just ignore them and just believe in yourself that yes, you can do it. So my suggestion would be break the myth and look into the facts. The two things that are essential for doing good mathematics is number one, this one, which is called staying motivated, and number two, this one, which is called a level of patience. So let us discard all those myths. Let us discard what the human brain and which part of human brain is responsible for doing mathematics, because here we are dealing with the minimum mathematics and I can assure you, you can do it. Just be motivated, believe in yourself that you can do it, and have a little bit of patience, because this is something which I talked in my earlier video, is a kind of a science which accumulates slowly, step by step by step. So it needs some amount of time. Now, before going into the mathematics, first I am coming up with this part, which is called the minimum physics that you need, because as you understand, this channel is physics for students. So definitely along with the mathematics, physics serve as an important role. It plays an important role. So what is the book that you would read in order to know the minimum physics? The famous Professor Leonard Susskind's The Theoretical Minimum. Here comes the customer reviews, which is more or less 68%. I think it should go more. And these are some of the reviews from India and US where people have really appreciated. It is one of the best book. This is a very good book to start with. Good introduction to mechanics and so on. However, there's something which I want to tell you about this book. So just watch the video till the end, and by this time, if you have liked the video, please do not forget to hit on the like button and click on the subscribe to subscribe to my channel Physics for Students. Now this book no doubt is one of the best books which starts with the minimum physics and mathematics that you know, is divided into two parts. The first one deals with the classical mechanics and the second deals with advanced mechanics and something which you all know are called the symmetries. Now, when we talk about the reviewing the book, the classical mechanics part is divided into these three, these chapters. So it would start with motion, which will teach you differential calculus, then the dynamics, mass, acceleration, force, then the systems of more than one particle. Then Professor Susskind would teach you on momentum and phase space, reaction and conservation of momentum, energy which leads to force and potential energy, and the principle of least action, followed by the derivation of the Euler-Lagrange equation. So this completes the discussion of classical mechanics, and then the book deals with the advanced mechanics and symmetries, where there are partial differentiation, symmetries, Hamiltonian mechanics, symmetry engine, energy conservation, Poisson brackets, Levi-Civita symbols, rotors and precision, electric and magnetic forces, and gauge invariance, charge particle motion in uniform magnetic field. Now, if you want me that yes, this is one of the best books because it actually deals with everything that you need to know, I mean it's obviously minimum, then I would say these are some of the very vital important points. Number one, the book contains just everything that you need. Because it is a minimum, the book title is Theoretical Minimum, so obviously you won't have an in-depth analysis of each and every chapter. So this is obviously the minimum. It contains more physics than mathematics. Yes, physics is more predominant in this book rather than dealing with mathematics, and nothing is covered obviously in depth, but it gives you a fairly good amount of understanding that what is the minimum physics and mathematics topics that you need to know. Also, you might have to go and take other reference books from the library or otherwise in order to read, because as I told you, nothing much is covered in depth. But this is a book which will give you a complete clarity in terms of the methodical approach, the way, the steps, and how you should be learning and what is the basic physics that you want. Now, it might happen that when you are learning the classical mechanics part, you have to consult some other books of classical mechanics, etc. Go back to the Newtonian mechanics, but that is good. At least you really don't have to hunt through and ask this question that what amount of physics, what is the topics, and how I should start with. So this book is good enough to give you a complete, I would say, chronological, step-by-step, clear understanding of the physics part and the mathematics part that you need. Now, I would now come to tell you more about what is the minimum mathematics that you need. And remember, this book which I am recommending is more on the mathematical part, less on the physics part. So here is the book, All the Math That You Missed, but you need to know to graduate school, and it was written by this famous author Thomas A. Garrity. As you can see, he was born in 1959, completed his bachelor's from the University of Texas, and he attended Brown University. So I always tell that you need to check the authenticity of the author. So Thomas Garrity actually stands at far beyond the level which we are thinking. So here is the book which I would like to talk, and it completes and gives you a comprehensive understanding of the step-by-step methodical approach in how will you understand the math. Now, few note about this book. First of all, there are two targets of this book. The first is that it aims to give you an overview of the topics expected at top graduate schools. So again, as I have underlined, remember that this is just an overview of the topics. The second is that it serves is to provide a list of advanced mathematical topics that might have a broader value beyond the, I would say, progressing a degree or getting a marks, with reference to further readings. This is quite important because again, as I told you, that this will be again the minimum. So you need to go back in order to understand. So these advanced topics might not serve as a direct understanding or getting a grade or scoring a good marks in your immediate semester examination, but it has got a far-reaching implication in terms of enriching the human brain and going beyond that and getting a better philosophical and deep, profound understanding of mathematics. So, as I told you, the book is comprising of two parts: the mathematical foundation, which deals with these topics: linear algebra, real analysis, complex analysis, countability and the axiom of choice, algebra, Lebesgue integration, Fourier analysis, differential equations, combinatorics and probability theory, followed by algorithms. The advanced topics are point set topology, differentiating vector valued functions, classical Stokes theorem, differential forms, which I'm going to talk, which I really liked about this book, curvature of surfaces, and the geometry. Let me give you an idea what is the content of the book. I have covered in details. So here are the content of the book. It starts first with on the structure of mathematics, and you should read what it actually tells on the structure of mathematics because it is wonderful. I'm keeping it as a surprise so that you can read this book. So here is the brief summary. Linear algebra starts with the basis of vector space, basis and dimension, determinant, etc. Then it goes for the real analysis, which starts with continuity, differentiation, integration, the Weierstrass M-test, and you can see that each and every chapter has got an exercise and books. That means it gives a complete idea that you should go and either you can read these books or some other. Then comes the calculus for vector valued functions, the inverse, the Jacobian implicit function theorem. As you can see, it also comprises of point set topology, metric spaces, others, classical Stokes theorem, path integrals, surface integrals, curl, orientability, etc. Then the differential form of Stokes theorem, including the volumes of parallelepipeds, differential K-forms, tangent spaces, everything is being covered. Also, you can see that curvature for plane surface, this is a part of differential geometry actually, Euclidean hyperbolic elliptic geometry, and the complex analysis is also covered, including conformal maps. This part is the probability, the 10th part, Gödel and independence proofs. That is wonderful. You learn about Gödel's incompleteness theorem, axiom of choice. Then comes the algebra, which starts with groups, representation, ring theory, Galois theory, etc. and so on. Here is the Lebesgue integration, the Fourier analysis, the differential equations which are covered, the basic. Also it covers in one way good, it covers the heat equation, wave equation, independence, expected values and variance. And finally you can see the 16th chapter comprises of algorithms, and it goes up to P equals to NP problems and so on. So I can tell you that this book is almost covering every single thing that you need to know, either on the basic level to know the mathematics, or what I can say that it will take you to advanced level mathematics in some way. But as you understand, as I told you, this book is primarily concerned with the mathematics part, not much with the physics. Obviously heat equation, wave equation, Laplacian, this comes, but primarily it is a math oriented book. So here comes the review of the book. So what I would say is that, remember, the objective of this book is to give the student or researcher how many topics that you should know. Now you can plus and minus based on your semester examination, based on your objective, how much you would learn, but it gives you a very exhaustive topic. Each chapter provides an overview or an outline of mathematical area in which you may be interested with definitions and proofs. Definitely, this book is not for beginners, and this book does not teach you mathematics. So if you're thinking that I will learn calculus, I will learn linear algebra, no. I repeat, no, you are wrong. This book is just a comprehensive list with the references which are given to do further study, further research, but it will not teach you mathematics. Compared to this book, I would say Leonard Suskind's Theoretical Minimum will give you an understanding or teach you mathematics. But remember, if you have seen this book in somebody else's video or blogs, etc., and they are suggesting you to purchase this book, I really don't have any objection, but please go through a proper understanding before investing your money, because as far as my knowledge goes, and I have gone through the book entirely, I have seen that it is absolutely not for beginners. It does not teach you mathematics. It gives you just an outline of mathematical area, but it is very exhaustive, and you can just learn from other books, but do not expect that this book is going to teach you mathematics. Now, all these 16 chapters which are covered, I mean to say the 16, I won't say chapters, topics, most of you know what would linear algebra give, what would real analysis give, complex analysis leading to quantum physics, etc. But I would like to give you a little bit idea about something which is a little bit, I would say, unconventional. One is the countability and axiom of choice, Lebesgue integration, point set topology, differential forms, and Stokes theorem. What is the benefit of that, and why will you read this book, and how it is going to help you? Now you see, countability and the axiom of choice is basically speaking about probability. But the good part of this book is that it actually speaks of axioms of choice, which is a kind of a powerful assumption used in various theorems, and it actually leads to certain philosophical debate in terms of Cantor's paradise, etc. So I mean to say, you can read this book or you can go through axioms of choice, because it gives you a profound, deep understanding of the philosophy of mathematics. And this is used in advanced mathematics, logic, and computer science. So this is something which you will get out of this. And these are the topics. You can just see 201 to 211 pages. Do you think the probability can be taught in those 9 pages? Absolutely not. So that is why I'm repeating that this would give you an idea of the choice of topics that either you will take or you will drop it. So this is one. Lebesgue integration, actually if you're learning further mathematics, there is something called Riemannian integration. So it generalizes Riemannian integration. So it is, I would say, a more advanced form of integration compared to Riemannian integration. So the practical usage, you can say it is used in functional analysis, stochastic processes, applied mathematics, and Lebesgue integration is also used in probability theory, yes, some part of quantum mechanics, and analyzing some complex physical system. So again, as I was telling you, see the Cantor set comes in between. So again, just 10 pages completes Lebesgue integration. So it gives you an exhaustive topic that these are the things that you should learn. How do you learn is up to you. This book is not meant for teaching you right from the beginning. Now what point set topology is also important because now topology is coming up. So algebraic topology and mathematical physics, these are using point set topology, and as you can see, it covers metric spaces, basis for topologies, Zariski topology, and commutative rings, a lot of advanced topics. Now what I particularly liked about this book is this one, differential form and Stokes theorem. Now the practical usage, if I say, then differential form is, it is calculus, but taking it to a little bit more advanced level. So it is used widely in differential geometry, especially in engineering, for expressing geometric and physical laws. So the theorems are also used in electromagnetism. And now you see, compared to any other topics, differential form and Stokes theorem is dealt a little bit more in details. So 111 to 143, that means how much? Around 32 pages, round about 32 pages compared to those 11 pages. And that is the reason I want to show you now something great, that the physical interpretation of the divergence theorem, which is being dealt with a a great example of a flowing river. This is something which I really enjoyed. So this is something brilliant. So if you want to know how the divergence theorem actually works and what is the practical, I won't say practical, I would say a kind of a visual interpretation of divergence theorem, this is the book which you can look for. Also, I particularly like physical interpretation of Stokes theorem. I've gone through many books which deals with Stokes theorem, proves the Stokes theorem, but this is something excellent. Again, the usage of a ball and the usage of a flowing river, I can say this is tremendous. This is one of the best explanations this book has. So I just showed you, it is gone through the step by step of what is a differential form and then further explaining about Stokes theorem. Now, if you talk to me and if you ask me, well, what is my honest opinion, then I will say it is an advanced level mathematics book. It does not teach you mathematics. It gives you an overall idea. If you are willing to learn mathematics, this book is not meant for you. And this book has reference to any other book, many other books, which definitely you can go ahead. Or I have also referred many mathematics books in my videos, which you can go ahead and learn. Just remember that Thomas A. Garrity's book is definitely great, especially for Stokes theorem, divergence theorem. It has got a superb explanation, but it will give you at least a chronology, at least the way that, okay, let me understand that this is the level of mathematics and these are the topics that I should learn in order to become what I call mathematically literate. So that's all for today's video. Thank you very much for watching and taking up your time. If you have really liked my video, please hit on the subscribe button and click on the bell icon to get all the notification from Physics for Students. This is my email ID which you can write, and this is my other channel which I put more videos on general theory of relativity. You can follow me on my Facebook, LinkedIn, Instagram and Twitter account. Physics for Students will be soon back with more interesting videos, but till then, goodbye.